All right, let's take a look. The first thing I do is I find the x-intercepts. So the way that I do that is I say, okay, if I want an x-intercept, if I want something on the x-axis of my graph, I need the y to equal 0. So I say, okay, well, instead of x squared minus 4x minus 12 equaling y, I'm going to say, oh, I want to make it equal 0. And then I'm going to solve by factoring. That looks like this. I need two numbers that multiply to negative 12, add to negative 4. So I know that to multiply to a negative, I need one positive, one negative. For 12, it could be 12 times 1, 6 times 2, 4 times 3. Since it's going to be one positive, one negative, they're going to subtract. And so I'm looking for two numbers that have a difference of 4. That's this. Since I wanted to add to negative 4, I'm going to make the larger number negative. Okay, so now I have this times this equals 0. So either x plus 2 equals 0, in which case x equals negative 2, that's this x-intercept. Or the other possibility is that x minus 6 equals 0, which means that x equals 6. I'm going to go ahead and graph negative 2, that's my left x-intercept, and my right x-intercept. For my y-intercept, I know that's going to be a point on the y-axis. The only way a point lands on the y-axis is if x equals 0. So I'm going to take my equation, y equals x squared minus 4x minus 12, and instead of the x, I'm going to plug in 0. So this just becomes 0 squared is 0. This becomes 4 times 0, that's also 0. 0 minus 12 is negative 12. So here I got negative 12 as my y value. Remember my x value was 0. So that's this point, 0, negative 12. Now on my graph, I can look, I know the axis of symmetry is going to be right down the middle. So here's my two x-intercepts. My guess is my axis of symmetry is right here. I can visually see where it should be. I think it should be on x equals 2. Let's see. We're going to do the math, and we're going to know if I'm wrong. It's going to show on my graph. Okay, so here's my equation. Notice for my equation, it's always ax squared plus bx plus c. So here, my a is this invisible 1, and my b is negative 4. So my a is 1, and my b is negative 4. So this is negative b, that's negative 4 over 2a. So negative 4 becomes positive 4. This is over 2, and that equals 2. Okay, I got 2. My axis of symmetry is at x equals 2. Let's say the most common mistake to make here is to forget that this is negative 4, and I would have gotten negative 2. And then when I went to graph it, I would have been like, oh, that's not right. That's not down the middle, right? So you can catch your own mistakes. Now, I know I can visualize my parabola right now. It's going to look something like this. So my vertex is going to be somewhere on this line, on this x equals 2 line. So I know my x value is 2. I'm going to plug in, and I should get a vertex. I should get a value in these y value ranges, right? Because I can kind of imagine what my parabola looks like already. So my equation is x squared minus 4 times x minus 12. And this time I'm saying, oh, I already know the vertex is going to be on an x value of 2. So let's plug in 2. 2 squared is 4. Negative 4 times 2 is negative 8 minus 12. You can just put this whole thing right in your calculator, but 4 minus 8 is negative 4. Minus 12 is negative 16. 2, negative 16. And when I graph this, that's the point. Look, 2, negative 16. That's my vertex. And you can see that my parabola looks pretty good. All right, there it is.